Let's take a look at the algebra of functions. I have given you two functions here, f of x and g of x, and we're being asked to find f plus g of x. Well, this is going to be f of x plus g of x, and I want to caution you of something. This is not the of x getting distributed here, because that makes it look like we have a multiplication model. It just happens that it turns out to be the same notation, but this is not a multiplication of f plus g times the of x. Do not get that confused. Basically what we have here is x squared plus 3, which is function f, getting added to x minus 2. And so when we combine these together, we get x squared plus x plus 1 as f plus g of x. When we're dealing with subtraction, you've got to be careful to distribute the negative. Here we're going to have x squared plus 3 minus the quantity x minus 2, and that's going to have you distributing a negative, and that's where we tend to make the mistake here. This will be x squared plus 3 minus x plus 2, giving us a final expression, x squared minus x plus 5. So please be careful to distribute your negatives. If you are asked to find f times g of negative 2, you can basically find f of negative 2 and multiply that by g of negative 2. And that means substitute in negative 2 for x in each of these portions. And so we're going to have negative 2 squared plus 3 times negative 2 minus 2. So our first expression is going to equal 4 plus 3, which is 7, times negative 4, and that will give us negative 28. Now we switch to a whole new type of notation, and it looks like we have a little degree symbol here. That is the composite symbol. This is f composite g of x. And basically it means we take our x value, substitute it into g to get g of x, and g of x then gets substituted into f of x. This is a substitution sort of notation, and the function closest to the of x gets substituted into the one further away from the of x. Now if you think of function f as saying, I am input squared plus 3, that is x squared plus 3. The input is g of x, which is x minus 2. So x minus 2 gets substituted into the other function. And so what we have here is, well, let's FOIL this out. X minus 2 times x minus 2 plus 3. That is x squared minus 4x plus 4 plus 3, which gives us x squared minus 4x plus 7. If you have g composite f of x, it's f getting substituted into g, and g says input minus 2, where the input is x squared plus 3. So this expression is going to equal x squared plus 1. Now we have a composite notation which has us evaluate. There are two ways to do this. Let's look at way number 1. If you look at part D above, so I'm going to say from D above, comma, f composite g of x is equal to x squared minus 4x plus 7. We already know what f composite g is for any value of x, so we can substitute 3 in for x here and say f composite g of 3 will be 3 squared minus 4 times 3 plus 7. And that will equal 9 minus 12 plus 7, which is going to equal 4. That is one way to do it, but you already have to know what f composite g of x is. There's a second way to do it, and this way number 2 basically has you start from scratch we have f composite g of 3, and you take g and substitute 3 and substitute it into g, and you take the output or range of that and substitute it into f. So let's do it this way. If we find g of 3, that becomes input 3 minus 2, which equals 1, and then 1 becomes the input into function f, and so f of 1 becomes 1 squared plus 3. We then have 4. Now that's a two-step process, but the value of that is you can do it directly, whereas up above you had to have already what f composite g of x was. So I say the following: if you already have the f composite g, use that approach. If you don't have it, use this two-step approach. Now I have 3 new functions given to you, and we want f composite g of x, and that says take g and substitute it into function f. Function f is the square root of input plus 1. So that's the square root of input plus 1, and the input g of x is 2x minus 5. So you can see that this is going to become the square root of 2x minus 4. If we are asked to find h composite f, f gets substituted into h, and function h says square the input and minus 3. So square the input minus 3. Well, function f is the square root of x plus 1, and so when you square that radical, you just get x plus 1 minus 3, and that will then equal x minus 2. Now let's look at g composite h of 5. I don't have g composite h of x yet, so I'm going to do this as a two-step process. I'm going to begin by finding h of 5, which is 5 squared minus 3, which is 22. And I will take that value 22 and substitute it into function g. g of 22 will be 2 times 22 minus 5. Well, that's 44 minus 5, which is equal to 39. Notice how I took the 5, substituted it into h, and got 22, and took that output of 22 and substituted it into g to get the final answer of 39. Now let's find g composite g of 3. I'm going to find g of 3 to begin with, which will be 2 times 3 minus 5. 6 minus 5 is 1, and that output will then be the input back into g, which will be 2 times 1, that's 2 minus 5, which is negative 3, which is the answer to this composite function.